Today we talk about the big factorials, a Hackerrank problem. We should calculate and print the factorial of a given integer. Now, that should be really just a simple for loop, and well, we carry the product and multiply each number with the previous number, and that is the result. But really, here we see that our n, the requested number, can be as high as 100, and that poses new challenges. Now, let's try to choose our biggest container for like the C++. For a C++ variable, it is the unsigned long int. Now that could be at least 64 bits. It could be 128 bits. Now the maximum value of a 64-bit is this number right here. And when computing the factorial of 18, we can see that it's already larger than a 64 value. So yeah, we will run into an overflow right here, and thus we can't store our variables. This is not a proper container for our numbers. Now, obviously the solution here is to choose another container, and well, the container of choice, I can't think of anything other than strings. Now we need to implement our own multiplication algorithm because we can't really just multiply numbers right here, multiply strings. We need to implement that algorithm, and that is really what the Hackerrank problem statement is asking us to do. Now, of course, our numbers would be stored in strings. We need to implement our big factorials algorithm, and we carry the result, of course, in a string. Now, multiplication done with strings. It is textbook multiplication. So what we do really is we multiply each digit with a number 1 with each digit belonging to number 2. Of course, we compute the product, we carry anything, we add the carry from previous operations, and of course if the number is bigger than 10, then the first digit will be the result, and the new carry is the second digit. Of course. Now, the index of the resulting index is the sum of index 1 and the sum of index 2. So let's say it's the third digit within number 1 and the second digit of number 2, then the resulting index will be 5. 2 plus 2 is equal to 5. Of course, so let's try to implement this solution. So let's try to include the IO stream, and of course we need to include the strings. So we use the cd, of course. Now, what we do in our int is extra long factorials of, let's say, 25 and return 0. Of course, let's try to implement that function. So that will be a void extra factorial int n, of course. Now we need to implement our own multiplication. As we said, string multiply, and the variables will be strings, so it will be a const string, and let's try to add a reference, this one, and a const string s2, of course. Yeah, there will be, and at the end we result. Yeah, so for the extra long factorial, it will be just as simple as a simple factorial loop. So what we do, yeah, let's string number and string follow equals 2 because one wouldn't matter because that would be the same number. Include to string. Yeah, of course, because our variables will be stored in strings, and so we start with number 1, and each time we call the number, the resulting number will be the result of the multiplication of the previous number with this number right here. And at the end, we will print that number and flash the buffer. And it's giving me an error here because, yeah, I made this stupid error naming the same variables twice. So, yeah, of course, now it should work. So let's go to our multiplication algorithm. So what we need to know is the length of each variable. So let's call it u and v. U for the length of variable s1, the one for variable s2. So we will need these two values. And we need, of course, the carry. Should be 0 at first, nested for loops. Int e will go, well, we'll try to variable e go from reverse order, like from u down to 0, because for strings, if this is the number, then if we want to start with number 0, then that would be the index number 5, and then 4, and then 3, and then 2, and then 1, and then 0. E would start with u, and while e is bigger than or equal than 0, and we do the same thing for the second number, and we need to have the length of our output resulting number. So let's store that in a variable. Let's call this L is -1. So this is the total length of the resulting variable, and let's store the results of the multiplication in the variable R. So as we said, we need to know the index of the resulting digit, and that is simply the sum of digit 1 and digit 2, which is E and G. So let's call that P. Well, as we said, it is the sum of the first digit, the index of the first digit, and the index of the second digit, except that it's not strictly E, it's U minus E, because we need to start from reverse order. So U minus E plus V minus G. And we need to check if we already have a digit in our resulting number. So like if the digit is 3, if our number was like, then we know that digit 3, we already have a number there, so we need to get that, to fetch that number, and we need to take that into account. Alright, so if O is bigger or equal to P, so if the length is bigger than our resulting index, then we know for sure there is numbers. So we need to store that number in our variable R of L minus P, I guess, minus digit 0. So this is the index within the output number. So if we had like a 4-digit number and we needed the third digit, then the index would be 1. So 0, 1. In order to obtain the number, we need to subtract a car from a car variables, so that only outputs the ASCII difference between the two characters, which incidentally is uh, like making int of that character. Of course, converting that character into a digit. Now, we need to get, secondly, we need to get the two digits, so that will be, and we need to carry the product, so that will be S1, and the digit is, of course, U minus E in the same room, and let's do our usual character difference conversion. That is strictly the multiplication of both digits, and if we have anything to carry, then we add that just as well. The first digit and we store it in the car, and the second digit we store that in our carry number. So what we need to do is let's implement a character for the results. Now of course, as we said, the carry would be r divided by 10. So if it's for example 81, then we get 8, which is incidentally our carry value. And the number, of course, our number should be just the model of that number. Now we need to compute the character value of this number here, of our first digit. We need to convert it into a char value. So that is really the reverse operation for what we did here. So it is 0 plus r. So these are common C++ techniques that you need to keep in mind, and you'll be using them every single time you deal with characters and numbers and strings, of course. We already have that digit right here. We only need to, if the resulting digit, let's say it's digit number 3, and our output strings have 4 characters, so for example, then we know that we only need to replace these digits right here. Otherwise, let's say if the result was like 22 and the resulting digit was at index number 3, then we need to place a number here at the beginning. Now we know, of course, that the difference between the output resulting index and the already obtained index will be just 1, of course, because we carry the loop one number at a time. So we only have to check that if is the total length of our output string is bigger than the resulting index, then we only need to replace that digit p equals, of course. Otherwise, we need to insert new digit at position 0, and we need the pointer to character WC, and it's just one character, of course. Now this is a proper multiplication, but we can still have a carry value after this inside for loop ends, after the last number. So we check here if we have a value, we still have a value into a character in the first digit, and we need to reset our carry to 0, and that is an implementation of the multiplication algorithm. And there is a simple mistake which is what Visual Studio is trying to tell me, and that is our implementation. Now what we need to check is that if we do have a value stored in our output, meaning if we did go through these loops, then we'll have a number here, and thus the length would be different than 0. So if it is 0, then we know that we haven't done this multiplication right here, and we need to just return. Alright, so let's test our algorithm number with n equal to 25. So we obtained our resulting value, and that is false. So there was just one small mistake, is that the index of our digits is actually E and G, not U minus A or V minus G. It's actually E and G. And with that modification in place, let's try to run our program again. And we see that the result here matches the sample output. So yeah, we submitted our code and it's validated on the submission points.